Example 4.1. In this example, we have a velocity field given by this equation where V0 and L are constants. We need to determine the location at which the flow field has a speed equal to V0, and we also have to make a sketch of the velocity field for x greater than 0 by drawing arrows representing the fluid velocity at representative locations. The first step in the problem is to decompose the velocity into its components. We have the velocity as v naught L, and then we multiply it by x I plus y j. We have two components in this velocity, so we have a component in the x and a component on the y. The component in the x-axis is given by lowercase u, and we simply write negative v0 x divided by L, and a component in the y-axis which is lowercase v, and it's v0 L times y. The first step of the problem is to calculate the location at which the flow field has a speed equal to v0. To calculate the speed, we simply take the magnitude of the velocity and we make it equal to v0. The magnitude of the velocity is simply the square root of each one of the components to the second power. So we simply replace all the quantities inside of the square root, and we get negative v0 x L to the second power plus v0 L y to the second power. And then we do a little bit of math. So this is to the second power becomes positive v0 square x square L square plus v0 square L square y square. Notice that we have v not in both sides as well as L, so we could factor it out, and since it's to the second power we could take it out of the square root. So this becomes v0 L square root of x square plus y square. And we said that this speed, this magnitude is equal to v0, so we make it equal to v0 over here. Notice that v0 and v0 cancels. This becomes 1, so this becomes L is equal to x squared plus y squared. Therefore, any point that fulfills this equation will have a speed equal to v0. For example, if we have x equal to L and y equal to 0, this becomes L squared, 0, take the square root, it becomes L. Or we could have also 0 and y equal to L, and that would also give us L. The next step is to make a sketch of the velocity flow field when x is equal or greater than 0 by drawing different arrows in different representative locations. So we're going to select the locations that are provided over here in the drawing. So let's just start with this point, which is x is equal to L and b and y is equal to 0. If we substitute L, x into u, we find that the velocity is going to become negative v0. And if we substitute y into v, we find the velocity is going to become 0. So we're able to draw an arrow. Notice that it's going to be negative, so it's going to go into this direction. And the size of that arrow is going to be equal to the size or the magnitude of v naught. So let's do the location at 2L. So we have x equal to 2L, and once again y is equal to 0. We substitute, we find that u is going to be negative 2v0, and v is going to be equal to 0. So at this point we have an arrow that it goes also in the negative direction, but it's going to be twice as big as the one that we had at L, since the size of the speed at that location is twice as big. So if we do this process again, so now let's choose these 2 points over here. We're going to have that x is equal to 0 and y is equal to L. We substitute, and that gives us that u is equal to 0 and v is equal to v naught. And we are able to draw, so it's a positive velocity, so it's going upwards, and the size of the arrow is exactly the same size as this velocity that we have at that point. And then if we do the same process at x equal to 0 and y equal to L, we're going to find out that u is equal to 0 and v is equal to 2 v naught. Once again, this is going to be a positive arrow, twice as big as this, and the size of it is going to be 2 times v0. You could do the process for negative L, and you're going to notice that you're going to get the inverse of this. So it's going to give you negative v naught, and over here is going to be twice as big. So it's going to be twice 2 times negative v naught. And the way that you construct all these different points, you will be able to find the location at each one of these locations. You calculate the value of u and v, and then you will simply draw the component of each one of the velocities, and then you will draw the resultant force, which is the magnitude of the total velocity at that particular point. For more details, please see the complete drawing which is provided in your textbook.